awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Alright, conservation of linear momentum. So here we have 2 tennis balls on the table, and principle of conservation of linear momentum state that in an isolated or closed system, maksud isolated ataupun closed system adalah when there is no external force. Maknanya bila bola warna hijau itu bergerak ke kanan, tiada external force exerted on that object. So what happened after the collision? So we can see that after collision, both balls are moving in opposite direction. Bola merah tadi dia bergerak ke kiri, after collision dia patah balik ke kanan. Bola hijau dia gerak ke kanan dan after collision dia bergerak ke kiri. Jadi semua kena ingatlah semula the principle of conservation of linear momentum, that total of initial momentum equal to the total of final momentum. Okey, jadi sekarang kita akan tengok bagaimana kita nak apply conservation of momentum dalam dua situasi, iaitu one-dimensional collision dan yang kedua adalah 2D collision, iaitu two-dimensional collision. Okey, jadi apa yang dimaksudkan dengan 1D collision? 1D collision means that before and after collision, the object is moving only in X component. Okey, tiada Y component, tiada angle. Before and after, hanya ada X component sahaja. Alright, so let's discuss the first case yang melibatkan one dimension collision. So here we have mass 1 and mass 2. So before collision, mass 1 will move to the right. So the initial velocity u1 must be positive value. And mass 2 initially before collision, it moving to the left. So dalam calculation, u2 equal to negative value. And what happened after collision? Let's say after collision, mass 1 will move to the left. So v1 must be negative value, while second mass m2 will move to the right. So f2 must be positive. Ini yang paling penting dalam you punya calculation. Positive and negative, tengok betul-betul. Okay. So now back to the principle of conservation of momentum, that total initial momentum is equal to total final momentum. Alright. So initially we have two object. Kita ada dua object. So before collision, iaitu total initial momentum, mestilah momentum initial 1 plus momentum initial 2. Okay, sebab tu kita tulis PI1 plus PI2 equal to, so final kita still ada two objects. So momentum final 1 plus momentum final 2. Okey, kita totalkan momentum kedua-duanya bagi kedua-dua situasi, iaitu before collision and after collision. Alright, so now we can expand the equations since the equation of momentum P equal to mv. Therefore, untuk initial, untuk object 1, so dia akan jadi m1u1 plus object 2, initially object 2, moving to the left, so dia akan jadi m2 times negative u2 equal to, so final condition, m1 is moving to the left, so negative v1 and plus momentum final for mass 2, m2 v2. So mass 2 after collision it's moving to the right, so v2 is to the right, so positive value. Okay, so now let's proceed to the second case. So here we have case 2, where now M1 and M2 still moving in opposite direction before collision. So remember, U1 positive, U2 negative. So what happened after collision? Let's say for case 2, object M1 dan M2 moving to the right. Both are moving to the right. Okay, mereka tidak bergerak sama-sama, mereka bergerak berasingan. Ada dia punya final velocity sendiri, tetapi kedua-duanya bergerak ke kanan. So V1 must be positive and V2 also must be positive. So let's substitute in this table. So remember that U2 must be negative value. Alright, but V1, V2 dan U1 is positive since the direction is to the right. Okay, and macam mana pula case yang ketiga? So let's say here, before collision, we have M1 which is moving to the right, but M2 is not moving. U2 is equal to 0 meter per second. Okay, and after collision, you can see here, M1 and M2 are stick together and they are moving to the right. So the mass of M1 must be combined with the mass of M2. Now look at the equation Pi1 plus Pi2, since we have two objects, equal to Pf1 plus Pf2. So let's substitute in this equation. So we have M1U1 plus M2 and then U2 is 0 equal to M1 plus M2 because they are combined together and they are moving with the same final velocity V. So, kita hanya letak V sahaja. Tak ada V1, tak ada V2. Okay? So, please write the equation correctly. So, how about 2D collision? So, 2D collision, when before and after collision, the direction of motion for both objects are involving X and Y components. Okay, so now let's look at the first case. Di mana untuk case yang pertama ini, mass 1 akan bergerak ke kanan. So, U1 must be positive value because the direction is to the right. And M2 is stationary, tidak bergerak. So, U2 is equal to 0 meter per second. And what happened after collision? Let's say after collision, the question state that mass 1 is moving in a direction of V1 seperti yang ditunjukkan dalam rajah, di mana the angle is 30 degree to the horizontal. Okay? Dan bola yang kedua bergerak ke bawah at angle of 60 degree to the horizontal. So, kita ada final velocity for ball 1 is V1 and final velocity for ball 2 is V2. Di mana after collision, kedua-dua objek bergerak pada arah yang melibatkan angle. Okay? So, V1 30 degree while V2 is 60 degree. Jadi, bila melibatkan angles, we need to resolve V1 into V1X and V1Y. Ingat lagi ke bagaimana nak resolve vektor? Ini paling penting dan jangan lupa. Okay? And V2, kita resolve kepada X and Y komponen juga. So, kita ada V2X dan juga V2Y. Make sure equation untuk V2X, V2Y, V1Y and V1X tulis betul-betul. Okay? So, V2Y, jika perhatikan, kita ada negative sign because the direction of V2Y is downward direction. So, now let's write two equations. melibatkan X component dan Y component. So, kita ada before collision, total initial momentum equal to total final momentum. Yang color biru melibatkan X component only. Okay, so before collision, since ball 2 is not moving, that's why U2X is equal to 0. Kita substitutekan nilainya adalah 0 because the object is at stationary. And before collision, kita hanya ada nilai initial velocity untuk ball 1 sahaja, U1X. And then after collision, since we have the value of V1X and V2X, so we need to substitute in this equation. Okay, pastikan nilai X masuk dekat equation X, nilai Y masuk dekat equation Y. Boleh. Bila kita tengok pada equation untuk Y component pula, before collision, both objects M1 and M2 are not moving in Y direction. Dia tidak bergerak in vertical direction ataupun Y component. Okay, that's why M1 U1Y saya gantikan dengan kosong. U2Y pun sama, kosong. Since tiada nilai U1Y ataupun U2Y. But after collision, kita ada nilai V1Y and V2Y. Make sure bila masuk dalam calculation, negative sign untuk V2Y mesti masukkan. Okay, so dia akan jadi 0 equal to M1 V1 sin 30 plus M2 times negative V2 sin 60 degree. Boleh? Okay, very good. Sekarang kita beralih kepada kes yang kedua yang melibatkan 2D collision, di mana before collision, we have two objects, di mana ball 1 bergerak di arah seperti yang ditunjukkan at angle of 30 degree. Dan M2 juga bergerak pada arah ini at angle of 60 degree. So, bila pergerakan objek melibatkan angle seperti ini, we need to resolve U1 and U2 into X and Y component. So, given that after collision, both objects are moving in a straight line, which is in X direction only, and they are stick together, so final velocity hanya ada satu nilai sahaja because M1 and M2 are stick together. Boleh? So now let's resolve U1 into X and Y component. So we're gonna have U1X and U1Y. Pastikan tulis equation dengan betul. U2 untuk objek kedua juga perlu kita resolve into U2X and U2Y. Ingat ya, U1Y the direction is downward. That's why equation untuk U1Y is negative 1.5 sin 30 degree. So given that mass 1 is equal to 1 kg and mass 2 equal to 3 kg. So let's write the equation in X and Y component. So yang color hijau itu adalah X component. So, kita boleh nampak M1 U1X plus M2 U2X. Since kedua-dua objek ada nilai U1X dan U2X, mesti substitutekan dalam equation. But the velocity of both object after collision is only in X component. That's why kita hanya ada nilai Vx sahaja. Okay? Dan nilai Vx itu hanya satu nilai sahaja, kerana mereka bergerak bersama-sama. Bagi Y component yang berwarna kuning itu pula, kita boleh lihat equation after collision, total momentum final equal to 0. Kerana apa? Kerana objek tidak bergerak in Y component after collision. Boleh? So, final equation for Y component equal to 1 times negative 1.5 sin 30 plus 3 U2 sin 60 degree equal to 0. Pastikan tulis equation betul-betul. Boleh? Okey, sekarang kita tengok kes yang ketiga pula, di mana kita ada dua objek where before collision, M1 is moving in X component. Okay, so U1 equal to 1.5 meter per second, but U2 is moving in Y component, which is upward, so U2 is given equal to positive 2 meter per second. And what happened after collision? Let's say for this case, both objects are stick together and they are moving in one direction at angle of 30 degree to the horizontal with the final velocity of V. Nampak dekat situ? Ada deflection of motion. So, kita perlu resolve V into X and Y component. So, Vx equal to V cos 30 and Vy is equal to V sin 30 degree. Make sure the direction of Vx and Vy are resolved correctly. Boleh? So, now, let's write the equation. And given that mass 1 equal to 1 kg and mass 2 equal to 3 kg, so let's write the equation of X and Y component correctly. So, total momentum initial in X component equal to total final momentum in X component. Ingat ya, X dengan X, Y dengan Y. Jadi di sini kita lihat before collision, only mass 1 is moving in X component kerana ia bergerak ke kanan. That's why kita hanya ada U1X. U2X tiada equal to 0 since mass 2 only move in Y component. But what happened after collision? M1 and M2 are moving together so that we can combine the mass M1 plus M2 times V, where Vx equal to V cos 30 degree. Hanya ada satu sahaja Vx sebab mereka bergerak sama-sama. So finally, the equation of momentum, equation akan jadi 1.5, which is the initial speed of M1 times the mass M1 equal to 1 kg equal to 1 plus 3, the mass of mass 1 and mass 2, where Vx is equal to V cos 30 degree. Dan yang berwarna kuning itu adalah untuk Y component. Since mass 1 moving in X component only, so there is no value of U1Y. Okay, U1Y akan jadi kosong, tetapi nilai U2Y ada dalam gambar rajah yang disediakan, iaitu U2Y equal to 2 meter per second. And after collision, M1 plus M2 times Vy. So, Vy, based on the diagram yang kita dah resolve tadi, Vy, the direction is upward. So, positive V sin 30 degree. Pastikan tulis equation betul-betul untuk menyelesaikan masalah yang diberi. Jadi, sekarang kita akan tengok pula condition or characteristics for elastic and inelastic collision. Apa beza elastic and inelastic collisions? So, based on this table, we can conclude that total momentum for elastic and inelastic collision is conserved. Kedua-duanya, total momentum adalah conserved, where total momentum initial equal to total momentum final. Tapi bagi total kinetic energy, untuk elastic collision, total kinetic energy is conserved. Means that total kinetic energy initial, iaitu before collision, equal to total kinetic energy final, iaitu after collision. So, bila kita kira, contohnya, when we try to calculate the total kinetic energy initial, iaitu before collision untuk kedua-dua objek, let's say kita dapat 5 joule, kemudian kita kira pula total kinetic energy final, iaitu after collision, dan kita dapat nilainya 5 joule juga. Jadi, kedua-dua nilai total kinetic energy initial equal to total kinetic energy final. So, kita boleh kata collision itu adalah elastic collision. Tapi, kalau kita kira total kinetic energy initial is not equal to total kinetic energy final, so the type of the collision is inelastic collision. Boleh? Okey, sekarang kalau kita nak lagi faham, kita mesti buat soalan dan kita perlu buat banyak latihan. Jumpa lagi dalam next video dengan soalan-soalan dan example untuk kita bincangkan. Assalamualaikum dan selamat sejahtera. Kita jumpa lagi dalam next video. Bye. Alright, we start with example number 1, where this example involve one-dimension collision. Okay, so let's read the question. We have 150 gram marble P. Alright, so I think I want to sketch marble P here. Okay, and then marble P moves with a speed of 8 meter per second, collides heads-on with a 120 gram marble Q. Okay, so we have marble Q, where marble Q move with the speed of 5 meter per second in the opposite direction. Okay, so we have another one here. Okay, so let's label first that this is P and this is Q. Okay, the mass of P is 0.15 kg. Make sure you change to kg, and Q is 0.12 kg. Alright, and initial speed of P, so we write UP equal to 8 meter per second. So saya ambil P to the right and Q is opposite direction to the left. Kalau awak nak terbalik Q to the right and then P to the left pun tak ada masalah. Make sure masa calculation positif negatif saja perlu betul. Okay, so since UQ will move to the left, okay, so let's draw the arrow. Alright, so UQ should be negative 5 meter per second. Okay, and then after collision, marble P move in the same direction. So what happened after collision? Alright, so the question state that marble P still move in the same direction. Alright, so this is P. Okay, and Q, how about Q? So let's sketch first. So we have, so after collision, so P still move to the right and the speed of P is VP equal to 2 meter per second. Okay, and Q, kita tak tahu Q, so kita akan ada VQ. Okay, so now this is before collision and this is after collision. By using conservation of momentum, we can write that total momentum initial equal to total momentum final. Okay, so this is the starting. Since this is one dimension collision, no need to separate X component and Y component. Okay, hanya satu saja. Kita ada one dimension means that objek ini bergerak in X component only. Alright, so now total momentum initial. So we have two objects, P and Q. So momentum for P, which is MP UP, plus initial momentum for Q, MQ UQ, and it's equal to, so final momentum, make sure mass darabkan dengan final velocity for P, VP, plus MQ VQ. Okay, so VQ ini yang kita nak cari, kita tak tahu berapa. Okay, so now we can straightly substitute. So ini saya rasa tak ada masalah. Okay, so the mass is 0.15, sorry. So 0.15 and UP is 8 plus mass of Q is 0.12 and UQ is moving to the left, so negative, jangan lupa. Alright, so this one 0.15, VP is 2 meter per second to the right, so positive, plus MQ is 0.12 VQ. Okay, so now we can calculate what is the value for VQ. So now VQ is equal to 2.5 meter per second. Alright, so since the value of VQ is positive, so means that the direction is to the right. Kalau berdasarkan gambar rajah kita ni, to the right lah. Sebab kita ambil right is positive, left is negative. Atau kita boleh tulis same direction. Okay, same direction as marble P. Okay, and then B, determine whether the collision is elastic or inelastic. Okay, so we finish A and we want to find B. We want to determine whether the collision is elastic or inelastic. Jadi kita kena ingat bila collision itu elastic. Okay, so bila elastic, so total kinetic energy initial kita kena kira mesti sama nilai dia dengan total kinetic energy final. Okay, but if the collision is inelastic, total kinetic energy initial is not equal to the total kinetic energy final. Okay, alright. So now let's try to calculate first. What is the total kinetic energy initial? So I think I want to use another color. Okay. So total kinetic, okay, so total kinetic energy initial is equal to kinetic energy initial for marble P plus kinetic energy initial for marble Q. Okay, so equation for kinetic energy is half mv squared. So ini adalah initial kinetic energy, so kita akan guna yang ni letak P bukan A, mp up squared plus half mq uq squared. Okay, squared ni saya highlight sebab ramai yang tertinggal. Okay, jangan tertinggal. Okay, so now let's substitute all the values. So we have 1 over 2 mp, we already know. So just substitute 8 squared plus half 0.12 and this one negative 5 squared. Okay, therefore the total kinetic energy initial you akan dapat 6.3 joule. Kira takut saya tersalah kira. Okay, and then for total kinetic energy final, so I think I want to use red color. Okay, kita buat kat sebelah ni. Total kinetic energy final should be kinetic energy final for P plus kinetic energy final for Q. Okay, sama juga half mp vp squared. This time we have vp because final velocity plus half mq vq squared. Okay, so masukkan semua nilai. So vp is 2, jangan lupa squared, and mq, the mass of q is 0.12, vq kita dah dapat tadi, kita dah kira 2.5. Okay, tak muat. Okay, so now total kinetic energy final saya kira saya dapat 0.68 joule. Okay, so kalau kita comparekan kedua-dua ini, kita boleh nampak that total kinetic energy, so kita sambung dekat atas ni kan. Okay, since total kinetic energy initial is not the same as the total kinetic energy final, therefore, okay, this is inelastic collision. Okay, boleh Alright. So finish example number 1. So let's look at example number 2. Alright, now example number 2. Here we have 2D collision. Okay. Nampak gambar rajah tu, kita ada angle. So kita ada X and Y component. So means that this is 2D collision. So here we have 200 gram tennis ball. So the purple color is the tennis ball moving with a speed of 15 meter per second, collides with a stationary ball. Yang color biru tu, okay, 800 gram. So let's highlight. So M2 is stationary. Okay, so the tennis ball is scattered at angle of 45 degree. So this is the tennis ball yang color purple tadi kan. So 45 degree, purple ke pink tu. Okay, purple nak ke pink kan. Okay. And the speed is given for the tennis ball. V1 is 5 meter per second. Okay. Find the final velocity, magnitude and direction. Bila soalan tanya pasal final velocity, kalau dia tak sebut magnitude and direction pun, mesti cari magnitude dan mention what is the direction. Okay. So kita nak cari V2 sekarang ni. We want to find what is V2 and we want to find the angle of theta 2. Because the direction is based on the angle of theta 2. Okay. So now, so since this is 2D collision, so kita kena buat satu-satu. X component dan Y component. Okay. So we start with X component first. Okay, so X component, so we write that total momentum initial X equal to total momentum final X. Kita buat X je dulu. Okay, so saya highlight dekat sini. Okay, ni cerita pasal X. Okay. And then, kita boleh tulis, since we have two masses, M1 and M2, so kita nak ada momentum initial for mass 1 in X component plus momentum initial mass 2 in X component equal to P final 1X plus P final 2X. Okay, so since initially objek M2 tidak bergerak, so dia takkan ada momentum. Ingat ya, momentum hanya untuk objek yang ada mass dan bergerak. P is equal to mv. So since before collision, mass 2 is not moving, so no momentum for M2. So saya terus saja potong kosong kat situ. Okay, so now let's expand the equation. Momentum adalah M. So we talk about mass 1, M1, U1X. Okay, plus 0, so tak payah tulis lah, equal to M1 V1X plus M2 V2X. So sekarang kat sini kita ada V1X. Okay, so since V1 kita tahu nilai dia 5 meter per second at angle of 45 degree, so kita boleh resolve V1. Okay, saya resolve dekat bawah ni ya. So kita ada V1 equal to 5 meter per second. So I want to resolve into V1X. So this is 45 degree. So V1X should be 5 cos 45. So bila awak kira, you akan dapat 3.54 meter per second. Okay, while V1Y, okay, equal to V1, saya terus gantilah, V1 is 5 meter per second. So dah akan jadi 5 sin 45. Tekan calculator, V1Y also 3.54. Okay, V1Y positif sebab dia upward. V1X positif sebab dia to the right. Okay, so kita dah boleh nanti masuk dekat sini. Cuma kita tak ada nilai V2X. Okay, V2X kita tak ada lagi. Tak apa, kita biarkan saja. And then kita substitute M1 equal to 200 gram. Make sure you change to kg. So 0.2 kg U1X. So since mass 1 is moving to the right, so memang dia in X component lah kan. So 15 equal to M1 0.2. V1X kita dah kira tadi 3.54 plus M2, soalan bagi 800 gram. Make sure you change to kg. And this is V2X. So now from here we can find already V2X. So V2X is equal to 2.87 meter per second. Jangan salah tekan calculator. Okay. So nilai V2X kita ni positif. So maknanya direction V2X kita to the right. So kalau kita sketch, maknanya V2X kita macam ini. So betul tak V2X kita to the right? Betul lah. Okay, kalau kita resolve, kita akan dapat V2X dan V2Y. Okay, so here is V2X and this is V2Y. So now let's move to the Y component. Okay, so we have total momentum initial Y equal to total momentum final in Y component. Alright, so saya ambil kali hijau. Okay, so what happen now? Sama juga macam tadi, kita tengok in Y component, kedua-dua objek initially tidak bergerak in Y component. Kan? Initially, both object are moving in X component. Okay, so dia bergerak dekat sini sahaja. Okay, so tak ada. So saya terus tulis kosong. Okay, so kosong kat situ. And it's equal to, after collision, so kita akan ada M1 final velocity untuk mass 1 in Y component plus M2 pun ada final velocity of mass 2 in Y component. Okay, so we can substitute all the values. So kita dapat M1 0.2 tadi, V1Y kita dah kira 3.54 plus M2 again 0.8 and V2Y. Okay, so from here you can see here we have unknown V2Y dan kita boleh selesaikan. Therefore V2Y is equal to negative 0.88 meter per second. Okay, so negative means that V2Y the direction is downward. So betul lah V2Y downward. And then the resultant of V2 di sini. Ini yang soalan suruh kita cari, V2. Okay, so in order to find the resultant velocity of mass 2, so V2 is equal to, ingat lagi tak formula ni? So V2x squared plus V2y squared. So substitute nilai V2x yang kita dah dapat tadi dan V2y yang kita dah dapat tadi. So the answer should be 3 meter per second. Okay, so ini jawapan untuk magnitude of the final velocity for ball 2. And then the direction, remember the angle. So tangent, inverse tangent, V2y over V2x. Please substitute the values. So you akan dapat, so ini saya akan ambil modulus. And then the answer for the angle equal to 17.05 degree, which is below positive x-axis. Okay, kalau kita tengok dalam gambar tu pun dia memang below positive x-axis kan. Sini tadi. Okay, the angle here 17.05 degree. Okay, so finish example number 2. Alright, now example number 3. Here we have ball A and ball B, and given that mass of A is equal to 2 kg and mass of B is 1 kg. Okay, A is moving to the right, so it's 4 meter per second. But for B, it's moving opposite direction. Tapi kita tak tahu berapa initial velocity untuk B. So after the collision, what happened? Ball A move at 30 degree from the horizontal. So dah lukis kat sini. And the velocity of ball A tak tahu juga. So VA and VB is moving at angle of 15 degree. But VB kita ada nilai, which is VB is 5.28 meter per second. Okay. So sekarang assume the collision is elastic. So calculate the initial velocity of ball B. So we want to find what is UB. Okay. So this is 2D collision. So make sure you do the calculation of X and Y components separately. Okay. So total momentum initial X equal to total momentum final X. So I will start the calculation with X component as usual. Okay. So now initially both object A and B are moving in X component. So kita akan ada MA UA plus MB UB equal to, and after collision look at here. So we have VAX, we can resolve. Okay. VA resolve to X component. So kita akan ada VA cos 30 degree. VA kita tak tahu nilai dia berapa. And then VY upward. So positive VA sin 30 degree. So kita boleh kira lah kot. Cos 30 degree tu tekan calculator, you akan dapat berapa? 0.866. Check And VY, okay, ini VAX, ini adalah VAY. Okay, so you akan dapat 0.5 VA. Okay, so another one VB. So VB kita ada kat bawah ni, VBY negative, okay, 5.28 sin 15 degree. So negative jangan lupa ya. So negative 1.37. And VBX pun jangan lupa. Tak muat kat sini. Saya tulis kat atas ni So VBX equal to 5.28 cos 15 degree. So VBX you akan dapat nilainya, cuba kira. Dapat tak 5.1? Okay, 5.1 meter per second. Okay, So now back to the equation for conservation of momentum. Okay, so final momentum in X component kita ada MAVAX. Saya suka tulis yang kecil ini. So saya tahu ini merujuk kepada X component. Okay, plus MBVBX. Same goes to this one. Okay, so now we can substitute all the values yang kita dah ada. So MA is equal to 2 kg, UA is given 4, plus MB is 1 kg, UB tak tahu berapa, MA is 2, VAX we already calculate here tapi macam tak lengkap lagi, so kita tulis saja 0.866 VA. Okay, plus VB 1 kg and VBX is 5.1. Kita dah kira dah tadi dekat sini 5.1. Okay, so therefore from here we can write that UB, okay, so this is UBX. Okay, so UBX tu UB lah, so kita akan dapat 1.732 VA minus 2.9. So since here we have two unknown UB dan VA, kita tak boleh pun selesaikan. So we need to let this as equation number 1. So what we want to do next? So we need to proceed to the second equation, where the second equation is come from total momentum, okay, initial in Y component equal to total momentum final in Y component. Okay, so this one is Y component. Alright. So now initially mass A and mass B are not moving in Y component. Okay, sebelum pelanggaran kedua-duanya hanya bergerak in X component only. Boleh. So initially dia akan automatic, saya akan tulis kosong. Okay, tak ada in Y component. But after collision, final momentum kita boleh kira lah. So in Y component ada, sebab kita ada VAY dan juga VBY. So saya akan letak MA VAY plus MB VBY. So let's substitute all the values. So mass of A and VAY kita dah kira tadi 0.5 VA plus MB is 1 kg, VBY kita dah kira negatif. Negatif jangan tertinggal ya. Okay, so negatif. So now from here, okay, look at here, we just have one unknown here, VA. So means that we can finally find VA first. So the answer is 1.37. Tapi soalan bukan suruh cari VA. Soalan minta kita cari initial velocity of ball B, UB. Therefore, okay, we substitute equation 2 into equation 1. Alright. So, UB is equal to 1.732. Okay, so let's substitute the value of VA, which is 1.37 minus 2.9. Okay, so UB, you akan dapat negative 0.53 meter per second. Okay, so look at here that the answer is negative sign since the direction of ball B is to the left. Okay, so kita pun dah dapat jawapan what is the initial velocity of ball B. Okay, untuk ini kita boleh bagi direction dia to the left, atau kita boleh cakap okay, to the left, atau kita boleh kata the direction of the velocity UB is opposite direction with ball A. Okay, so finish example number 3. Okay, now let's discuss the last example for this video. So we have 1500 kg car traveling at 90 km per hour to the east. So it's given that the blue color here is 1500 kg car. So we put as M1. Okay. And U1. So given that U1 is in 90 km per hour. So make sure you change to meter per second. Okay. And then for M2, so here we have M2 and U2. So I will write U2 60 km per hour. Okay, so before we start, I want to change first the initial velocity U1 into meter per second. So remember how to change the unit, kilometer per hour. Okay, you boleh buat satu-satu. Kalau you rasa takut silap, boleh buat satu-satu. Okay, kilometer ke atas, kilometer kat bawah. 1 kilometer is equal to 10 power of 3 meter ataupun 1000 meter. Okay, so kilometer kita boleh cancel. Hour dekat bawah, so another unit hour dekat atas. 1 hour, 3600 seconds. So cancel hour. So now you can see here that the unit is in meter per second. So we can write that U1 is equal to 25 meter per second. Okay, practice ya bagaimana nak tukar ni. And then U2 initially, okay, mass 2 or car 2 is moving in vertical component. Okay, dia bergerak ke atas, upward. And the initial velocity is 60 km per hour. Okay, so let's change kilometer. Okay, so we can cancel. And now we can calculate in meter per second. Okay, so the answer is 16.67 meter per second. Okay. So now let's start. So since this is 2D collision, so make sure you calculate separately for X and Y component. Sama macam tadi, saya akan tulis macam inilah. So this one should be final. Okay. So highlight sikit. So this is in X component. Okay, now kita cerita pasal before collision. So this is before collision, initial. And belah sini adalah after collision. So before collision, hanya car 1 sahaja yang bergerak in X component. Yang color biru ni. Okay, boleh Jadi macam mana pula dengan car yang berwarna merah ini? So, the second car is moving in Y component. Dia bergerak in Y component. Bergerak ke atas, to the north. Kan soalan dia kata. So, bila kita tulis initial momentum, okay, initial momentum in X component, okay, initial momentum in X component for contohlah car 1 plus initial momentum for car 2 equal to momentum final, okay, in X component car 1 plus momentum final in X component car 2. So kita dah tahu dah before collision car 2 tidak bergerak in X component. So kosong terus. Boleh? Okay. So, based on this diagram, okay, saya boleh resolvekan dulu V final into X and Y component. So, this is V final X and this is VY. Okay? Okay, so kita highlight sikit VY and this is V final X. Okay. So, now, let's substitute all the values. So, we have M1 U1, okay, M1 U1, okay, in X component equal to M1 V, okay, Vx. Okay, kenapa Vx sahaja? Saya tak letak V1x sebab after collision, okay, car 1 and car 2 are moving together. Okay, they are stick together. Okay, so dia akan jadi Vx sahaja. Saya tak namakan V1x ataupun V2x. So dia akan jadi Vx sahaja. Okay, so kalau kita susun, so dia akan jadi M1 plus M2 Vx. Okay, so ini adalah M1 plus M2. Sebab mereka dah bergerak sekali. Okay, so M1 is 1500, U1x is 25 meter per second. So kita tambahkan, okay, the mass 1000 for M2 and Vx. Okay, therefore we can calculate Vx equal to 15 meter per second. Okay, kita baru cari Vx, kita nak cari V. Ingat ya, nak cari V. So velocity after collision, so V kita nak cari, kita mesti kena ada Vx squared, kita dah ada Vx plus Vy squared. So sekarang kita nak cari Vy pula. Okay, so now Vy, so total momentum initial in Y component equal to total momentum, okay, final in Y component. Okay, so ini adalah, okay, momentum in Y component. Kita asingkan. So we can write equation. So, saya akan mulalah. So, before the collision, car 1 yang color biru itu tidak bergerak in Y component. So, dia akan kosong terus. Plus, car 2 is moving upward, okay, to the north. So, dia ada U2Y. Okay. So, kita boleh letak M2 U2Y equal to, after collision, they are moving together, right? So, VY. So, therefore, we can write VY is equal to M1 plus M2. Okay, we substitute all the values. Okay, and then over M2 is 1000 times U2Y. U2Y is given, so kita dah kira 16.67 meter per second. Therefore, VY is equal to 6.67 meter per second. Okay? So, finally, we can find V. Alright, so saya buat kat tepi ni. So, V is equal to square root Vx 15 squared plus 6.67 squared. Okay, so V, the magnitude of the final velocity for both car after collision is 16.42 meter per second. And what is the direction? Cari velocity, make sure you calculate the angle. So the direction is equal to Vy over Vx. Okay, and theta is equal to 23.97 degree. And this is above positive x-axis. Okay. So, kita dah jawab. Okay. So, finish all the examples for this video. So, insyaAllah kita akan jumpa lagi dalam video seterusnya, which is on chapter 4. Okay, awak doakan supaya saya boleh sambung video-video ini ke chapter yang seterusnya. Semoga anda semua support, share, like and subscribe this channel. Terima kasih. Jumpa lagi. Assalamualaikum dan selamat sejahtera.